So let's continue with the tutorial. We're pretty much at the end. We're gonna be working on drawing the timer view, which, if you remember correctly, it's the thing that we prototyped basically on the first episode, I think. The tutorial told us to draw this kind of like just a prototype, and we haven't touched it since then. So I think that's what we're gonna be working on. So Scrum Dinger tracks progress during daily Scrum meetings, giving each attendee an equal amount of speaking time. The app displays the meeting progress using segments of a circle to represent each speaker. When the circle is complete, all attendees have had a chance to speak. In this tutorial, you will create the views necessary to draw this progress view. Download the starter project, blah blah. Okay. So creating the meeting timer view. Meeting view shows the preliminary arrangement of views, but the central timer view is still a placeholder circle. Okay, so basically this guy, it's just a circle. Let's double check that. So yeah, we extracted the header and the footer a while ago, but yeah, the central thing, it's still just a circle. Okay, we're on the same page. In this section, you will creating the meeting timer view, which builds upon the circle to present a visualization of meeting progress. The meeting timer view will display the circle and the current speaker. Ah, that's cool. That's cool. Yeah, it's something I was missing all the time. Okay, so let's start by creating the new view. So once we have this, we need to cut the circle view from the meeting view and paste it here. Okay, so what we are doing is going here, basically cutting it from here and moving it. So that's gonna be the start. That's gonna be the start 24 and the earliest. Then we add a text with a Z stack. Okay. So we need to add a Z stack to present things, you know, one in front of the other with using the Z axis. And then we need to put a text, which I think by default is like right now we're just putting a default placeholder in there. And we want to put a padding horizontal to basically separate the circle from the borders. So then we want to add the properties for the Scrum color and the speakers. Okay, so this view needs the speaker for the name and I guess for the progress and all that stuff, and the color because I guess it changes the color somehow. So let's add these two properties, speaker and color. And it's interesting because one is a constant and the other it's a variable. And of course now, as always, every time you change something from the structure of your view, you always need to go on the preview and update it. And to be honest, at this point of the tutorial, like everything, it's already doing very similar things that we have done before, so I don't want to waste anybody's time just writing it myself. So the next thing is to add a computer property named current speaker that returns the name of the current speaker. The current speaker is the first speaker who isn't flagged as completed. If there is no current speaker, the expression returns someone. Someone is speaking. Okay. So let's analyze this line. So it's a computer property. Let me format it the way I want it to make it easier to read. So it's the speakers, then you have the first one that it's not completed, and then you get the name of that speaker. And if something is not there, we just say so. Okay. In theory, here it should just say Bill because scheme it's complete. But we're not using it yet. Okay. So yeah, we need to do the text current speaker. So here instead of this hard-coded string, we can use current speaker. And then we want to use title font for this text. There you go. Bill show up. Now, what else? So add the text view to display the speaking and wrap both text views inside the view stack. Okay, that's kind of cheating, right? VStack. Well, I guess because you're using vertical, maybe it's okay in terms of. I don't think. Yeah, I'm not gonna start talking about localization because this doesn't make any sense. Because what if some language wants to say, imagine that your language says is Bill speaking, something like that. These things, they are very nice for a demo. Like when your designer it's making it on Sketch or whatever they use these days. It looks very nice, but then when you start thinking that needs to be localized on all the languages in the world, then things are way worse. Like somehow like it's always a trade-off. It's like a lot of times it's a similar thing with accessibility. If you want to be much as languages as you want, and the same for accessibility, the more accessibility you put, sometimes you need to kind of like compromise a little bit on certain aspects, which is totally worth it because of course everybody should have access to the applications that we write. But it's something that if you get designs or stuff like that, it's sometimes hard to find the right balance. Something to keep in mind always. And of course, in this case, for the voiceover, it's super cool because we can just say, just combine all the children, and it's gonna just read this as once. It's like you're making all of these one single block. And then on the foreground color, to use the color of the scrum. Yeah, we're using the accessible font color. So the design is yellow, which means that's what we use when we show it here. So once we are here, because all this background is going to be yellow, we want to use the accessible color. We're not making it yellow. We're using that color to find the the dark or light, depending on that color with this accessible font color, which is the same thing we have used in the past. So that okay, gotcha. Meeting view, want to update the meeting view to use the meeting timer. Yes, so now we just have it there. Now we can just, so we pass the speakers and we pass the color. So as you can see, like this meeting view, it basically has all the knowledge, basically has the state and all that stuff. And because these views it's like we just are moving the code from one place to the other. These are very dumb views. They don't do anything special. So we literally pass the dependencies that it needs that are still stored here. That's a very nice and common way of separating the views and everything in SwiftUI. It's quite nice. So now we have this here, but I guess now we need to do it in a way that it's more fancy, So we're gonna draw an arc. It's super cool that this tutorial they kind of found a way of showing you everything kind of in SwiftUI, like from how to store data, how to draw, how to use like other frameworks like the audio that we played the other day. So it's a good tutorial that touches kind of everything, and so I'm quite happy that now we're going to be playing with drawing APIs because they're one of my favorite APIs. So we will create a single arc segment that traces a portion of the circle. So this thing here. This arc will serve as a building block for the next section, where we will draw multiple arc segments to depict the meeting progress. Oh, that's cool. I guess we're going to be kind of putting one segment for each member of the team or something like that. To create an arc, you will create a structure that conforms to the shape protocol. Yeah, the shape protocol has one required function, path in. You will write the path in function and initial properties. Yeah. The shape will use the number of total speakers to calculate the length of the arc. We would use the index number of the current speaker to know where along the arc each. So we are on the meeting view. We need to add a speaker arc. And that's a shape, it's not a view. Although the API is very similar, that's the nice thing about SwiftUI, that the API is very similar no matter what you do. But by that, what do I mean by that? So if you have a view, it's a protocol that you implement on your struct, and that struct just needs to return the body, which is the view. Now we're making a shape. And the shape, it's a protocol that you confirm to your struct. And what this shape needs to return is a function, basically that given a rect, you return the path, you know? But it's not only that. If you go and you make modifiers, it's exactly the same thing. A modifier, it's a protocol that you confirm in your struct, and it has a kind of like a single method you need to implement, which in that case, it's the same as the body, but it's a function because you can get past the original view and stuff like that. And then even further, when they added the app API, is exactly the same. It's a protocol that you implement on your struct, and instead, in this case, instead of returning the view, you return the scene. But it's all the time the same. So it's very nice because once you learn it once, you can apply the same principles over and over. Super cool. Okay, so let's see how we implement this path. So for the path, yeah, there are multiple ways of creating paths. You know, like you can use a CG path, or you can basically, there are some convenience to ellipses, round regs and everything. But I think in this case, usually what you end up doing is just using this callback based API where you get a path in and it's like a mutable path, you know, and you start mutating that path. It's the typical thing that you start drawing with lines and curves and all that stuff. Now we need some data to start doing the math. Because every time you're drawing, you're using math. Every time. Somebody told you that you don't need math when you're doing programming, you know, they are totally lied to you. Not super complex, but sometimes you need to go back and remember what you were doing in school. Definitely. In this case, let's hope it's not that hard. So we have a speaker index and the total speakers. So that's what they just explained to us, that we need these two pieces of data to basically calculate the progress over that circle mainly. So custom properties, you will base the number of arc segments, the total speaker indicates the speak. Yeah, perfect. And then we calculate So yeah, I was gonna say, like, didn't we do this already? But the one we did was, I'm not sure what it was in the footer, but it was for a percentage. And in this case, yeah, we have been calculating these kind of things, but every one is slightly different because in this case, it's over 360 because we want to fill the entire circle. So it's like 360 degrees. So it's not exactly the same. I wonder if like it was maybe easier to pass a progress on all these basically children views and just calculate the progress in one place, but I think it's fine. And then we need another one to know the start of the angle. I see. When you draw a path, you will need an angle from the start and the end, or additional 1 degree is for visual separation. I see. So we're making this a speaker arc, and we're going to be making multiple arcs to fill the circle with all the speakers. Makes sense? And that's kind of cool. It shows you like how you can compose not only views, but also shapes. You know, like you don't have to make one shape that deals with all the speakers and putting separations between them and all that stuff. Like you can just make one shape that draws one arc for one speaker, and then you compose them to fill the entire circle based on the speaker. And now we can implement the path function to create a constant diameter for the circle. So the diameter is constant, yeah, but it's based on the rect that it's given to us. So that's part of the framework. That framework takes care of that. So every time this is called, it's gonna be called when it needs it, and the rect is gonna be based on basically the view where this shape is being drawn. It's gonna take the size of that, and it's gonna give it to you. So you can basically make dynamic shapes here. And now we need to calculate the radius, which, I mean, yeah, diameter, it's just half of the radius, fair enough. And then what else? The origin. It's just the center of the rect, basically. So finally, we need to use this function here. So just so you can see what we have available, we can add lines, ellipses, but then there is a bunch of them for curves, quad curves, which is what I was working with in my project. And then we have arcs and relative arcs, you know, so a couple of variants. So if you want to define them with a tangent or with a center and stuff like that. In this case, we use the center, the radius, and now we have the shape. Of course, we are not seeing it because we are not using it anywhere. So now it's time to go to the view and actually start using it. So you can see how we have different segments for each speaker. We will draw a speaker, contain all the information to the segment. So we need to go after everything. So after we draw the circle and the text in the middle, we do a for each. So remember, at this point we're inside the Z stack. So by adding a for each here, we're gonna be adding these views on top of everything. And this for each is gonna go for each speaker. And because the speaker is identifiable already, this for each works, which is the nice thing about making the model identifiable. Instead of using ID here, you can use ID if it's just for once, you know. But if you're going to be using the same model everywhere on the app, it's much better to make it identifiable directly. Another speaker using the index at the count. Okay, so if the speaker is completed and we have an index for it, which I mean we should because we're iterating over the speakers and we're finding the index of the speaker. Yes, I mean you probably maybe you wanted to iterate over, you know, a zip of the speaker and sending numbers, so you could get both things. Makes it's much nicer to use zip than not to then have to go over the same array you're iterating to get the index from it. It's kind of weird, but whatever. And then we just put the arg. We have all the data we need. So we just put the arg in there. That's it. So we have the index and the total speakers, right? And then we need to rotate it. Basically, move 0 degree angle to, okay, yeah. Yeah, because without this, so by default we are basically drawing the circle here. So we need to basically rotate it with a rotation of minus 90 degrees. It basically moves it, whoop, and it makes this point go here. So it starts at what for us is, you know, 12 o'clock or 0 on a clock. So that's much more, you know, what we expect. So that's what we have. And now we add the stroke. Like, you should notice that without the stroke, basically SwiftUI, like if you think about what's happening here, this is a shape, okay? And the rotation, it's a rotated shape, so it's also a shape. So at this point, we don't have views here, but SwiftUI magically, automatically converts a shape into a view. And when it does that, it uses some defaults, which, as you can see in this case, is basically filling with the foreground color the shape. But we don't want to fill the shape, we just want to stroke it. So when we use this stroke, we're basically telling UI to convert a shape into a view using a stroke instead of a fill, you know. This, it's nice in the beginning, you know, but as soon as you want to do something very simple, you know, which is like have a shape and put a stroke on it and fill at the same time, you can't do that. And it's very annoying because you end up having to duplicate the shape and compose it with a background or something to draw the fill on the background and then the stroke on top of it. And it's something that you do so often that like you need to have some helpers for it, because I don't know, like it's I feel like you should be able to do a fill here, you know, but of course you can't, because you are filling a shape, not a view, but stroke returns a view, and if you do the other way around, you have the same problem. So one of these things that feels weird, but if you know how the API works and is implemented, it makes sense, but still, it's something that I wish there was a different API for these things, because it's something so common that, you know, it should behave a little differently. But well, anyway. Now, if we run, we would see what we did. And that's kind of it. I thought there was a little bit more. course, here it seems very simple because our preview only has 2 attendees, so there is not much to show. But if we run the full application, we will try one of these ones that has more attendees. Here we have 4, for example. If we start a meeting, we can see how, I mean, we're not going to see anything, but we should see how this is feeling. And if we go to this one, you see all it feel and with the same color as the background, this white color, which is the color of the meeting. And you can see this 1 degree basically of separation. And this is the last speaker. So when this finishes, it's gonna end. And if we, for example, try this one, which is 10 speakers and they have 1 minute, you can see that it goes, the timer goes much faster. If we go to the second one, you now see that, you know, like the arc is smaller, of course, because it needs to fit more people. Yeah, you see, I don't know if you heard the noise, but like there is the noise that we implemented the other day and it keeps going. Dude, but this stand-up, it's super fast. Crazy fast. That's how all stand-ups should be, by the way. So let's check our understanding. Which preview provider displays my view? Preview provider displays my view. So you need a binding with the names. So should be this one, right? No, it's this one because this is not static. So that's a very similar question that we had in the past. So yeah. Which code sample is a structure that conforms to shape? Struct, shape, struct, shape, struct, shape. Not a path, it's this one because it's a method, and it's a method because it accepts the rect. This doesn't make sense because if you don't accept any parameter, usually you make it a property. Next. Then the struct rectangle conforms to shape. How should you rotate the rectangle 45 degrees? You need to make the angle degrees, and it's a modifier. It's not like it's not a parameter that you inject when you initialize it. Could be this one, but you need to pass an angle. It's not just 45 because then you don't know if it's radians or degrees. But that's it. That was quite short. Maybe I made it too long because I commented too much of it, but it was not that long. And now we have a more polished version of the timer. That's pretty cool. The next thing is transcribing speech to text. Let's see how it goes.